Hello students, welcome to our second theory session of matter in our surroundings. In this session, we'll discuss about a process called as diffusion. Right? In an experiment, we had seen that when an empty glass jar is kept upside down over the beaker containing bromine liquid, the brown vapors can be seen on the glass jar also. Right? So that is what? That is diffusion. That is the process of movement of particles. So we'll be discussing about diffusion in this session and also about the nature of particles of matter. So let's start our session here, students. See, what is diffusion? Diffusion refers to the process by which molecules intermingle as a result of kinetic energy of random motion. The molecules of gases are in constant motion and make numerous collisions with each other. Diffusion is what? It is the process by which the molecules intermingle. It is the process in which the particles of one substance move into the other. Right? I can take the example of simple diffusion. There is the movement of different particles into each other or among each other. Say, for example, if you spray some deodorant or some talc or any perfume, if you're spraying it in your room, it can be smelled outside also. Why so? Because the particles of the spray or the aerosol which you are using, they start moving, right? They move, they collide with the particles of air, which increases their energy, right? And they intermingle or they mix with the particles of air. Fine? The molecules of gases are in constant motion and make numerous collisions with each other. So they are making collisions with each other, and they are moving at a faster speed. Now, this process of intermixing of gases is called as diffusion. This process of movement of molecules of one kind into the another. Say, diffusion refers to the process by which molecules intermingle as a result of kinetic energy of random motion. They are moving randomly, they are having some kinetic energy, and that is why they are mixing up. Now, what is effusion? Effusion, it is the escape of gas molecules through a tiny hole, such as pinhole in a balloon. Say, if you take a balloon, now if I put a tiny hole in this balloon, what will happen? Air will ooze out, or gas will just come out from this pinhole. Now, this oozing out of air or coming out of gas from this pinhole is called as what? Effusion. And diffusion is what? It is the movement of different particles among each other so that they become mixed uniformly. Or the process by which molecules intermingle as a result of kinetic energy of random motion. Right? So this is what is diffusion. All gases spontaneously diffuse into one another when they are brought into contact. Why so? Because gas molecules or gas particles, they are in constant motion. They are in random motion. They are composed of very, very small particles and they are in random motion. Right? So they diffuse into one another. And the gases, they've got the space, or the gases, they have got maximum space in between the particles. The particles are scattered in gases. The space between these particles is large. So easily the particles of other gases can mix over here. Like this. And they will be in constant motion. Like this. They will be in constant motion and they'll hit each other. Diffusion into vacuum will take place much more rapidly than diffusion in any other place. Diffusion means in vacuum, there is no gas. It is vacuum. Nothing is here. So the particles will randomly move into the vacuum. Say when air is there or any gas is there, so the particles of the gas or air, they will restrict the movement of other particles. Because these particles will collide with the particles of gas or air. But if there is vacuum, nothing is there. Nothing means nothing is there. So the gases will diffuse faster into the vacuum than in another place. Why it is written in another place? Because in other places, the other gases are also there. And the particles, they'll collide among each other. Both the rate of diffusion of a gas and its rate of effusion depends on its molar mass. That is the molecular mass. Lighter gas diffuse faster than heavier gas. So the lighter is the particle, more is its velocity. The more it will be its diffusion. Right? That is, the rate of diffusion is inversely proportional to the square root of the density of gas. The more is the density, the less is the rate of diffusion. The lesser is the density, the more is the rate of diffusion. You must be knowing what is density equal to. Density is mass per unit volume. Right? So the lighter is the gas, the faster is the diffusion. Fine. While colliding, students, some of energy is also released. So diffusion in vacuum takes place at a faster rate. Always remember, diffusion takes place from a higher concentration to a lower concentration. See, I'm talking about liquids. I'm sorry, we're talking about gas. See, the gas is from its higher concentration to the lower concentration. See, there's an experiment over here. These are two gas particles. These are two types of gases. Suppose this is nitrogen gas, which has got small particles of nitrogen, and this is oxygen gas. Right? Now, what is happening? These particles are in random motion. They are moving away in all the directions. Nitrogen particles are also moving. Now they are hitting the partition also. Both ways. Now if this partition is removed, then what will happen? They'll diffuse into each other. Now this, what has been done here? They have been intermingled. They have been intermingled over here. Now this is what is called as diffusion. Right? The process by which molecules intermingle as a result of kinetic energy of random motion is called as what? Diffusion. This intermingling. And escape through a pinhole is effusion. They both depend on the mass of the particle. How are they related? The rate of diffusion is inversely proportional to square root of density. What is density? Density is mass per unit volume. It means more is the mass, less is the rate of diffusion. So highest rate of diffusion is of hydrogen because it has got the least mass. Now in this case, all the gas particles have been intermingled. So this experiment shows the phenomenon of diffusion. Diffusion can be observed in our day-to-day life also. Say if you burn an incense stick, agarbatti which is called, you can smell it far off from the place where it is burned. Why so? Because the particles, the gas particles which are present there, they diffuse or they mix with the particles of air. or if you're spraying some deodorant, or if somewhere something is cooking, right? If somebody is cooking something, so that also you can smell. So that is due to the process of diffusion. The particles are in random motion and they collide with each other, right? Now these particles are in constant motion. You can also observe this. Say if in a dark room there is a small slit in the window or anywhere from where the light is coming inside. Now in this cone which is formed over here, you can find out very small particles moving in a zigzag manner. This particular motion, this is the motion of the particles. These particles, they are moving. They are in constant motion. I'm just telling you where you can see the motion of particles. So in a dark room with a slit from where the light is coming inside, you can see very small particles moving randomly. They don't have any particular direction. They move randomly, right? And this random motion of particle was discovered by Robert Brown, and this random motion of particles is also called as Brownian movement, right? So the particles of matter, they are in constant motion. They have a property of getting intermingled with each other. So this property of getting intermingled with each other is called as diffusion. The movement shown by the particles is called as Brownian movement because it was discovered by Brown. What he did, he took a bucket of water, he placed some pollen grains in it, over it. There he can see the movement of particles. So what he did, he just immersed some pollen grains into water and then observed it in the microscope. He found that these are in constant motion. The pollen grains are in constant motion. Then what he did, he boiled the water containing pollen grains. Then again observed it. He observed that the particles were moving more faster. Now this suggested that on heating, the energy of the particles increases and thus their speed or the motion also increases. Right? So the particles of matter, they are very small in size. They've got space in between them, except for solid state I'm talking. Then they are in constant motion. Now let's just brief the characteristics of particles of matter. The important characteristics of particles of matter are, first of all, the particles of matter are very small. The particles of matter are very small. How did we find that? Just few crystals or a pinch of indigo that is turning that whole lot of water, that is turning the color of whole lot of water. That is the color of 1 liter of water can be changed by just a pinch of any dye. It means that that pinch is made up of further very small particles. Right? So it was proposed by John Dalton that matter is made up of very small indivisible particles called as atoms. The particles have spaces between them. That is the color of that bucket of water changed. It means there was space or there is space. There is space between the particles. So if these are water particles, and in between the dye particles are there. The particles of matter are in constant motion. This was proved by Robert Brown. I have just now told you the experiment that he immersed small pollen grains in water and observed it in a microscope, and he found that the pollen grains, they are in random motion. Now this random motion of particles is called as Brownian movement. Now the next point is the particles of matter attract each other. That is, we can just elaborate it as there is some intermolecular force of attraction. Or there is some force of attraction between the particles of matter. That is, the particles of matter attract each other. Or there is some force of attraction between the particles of matter. Right? So it can be illustrated by, say if I'm taking a piece of chalk. I'm taking a piece of, let's say, iron and a piece of ice. Now, if I'm breaking this chalk with a hammer, it will not require a hammer even. If I'll just apply some force, it will break into pieces. I'll have to apply a very large force to break iron into pieces. And some intermediate force is required to break ice into pieces. Now, why am I requiring some force from outside? Because the particles, they have got the force of attraction between them. So the iron particles, they are tightly packed and the force of attraction is very, very high. Whereas in chalk, the force of attraction is less. In case of ice, it is somewhere in between. It means there are some sort of bonds are there in between the particles. We'll not discuss about bonds. It's just the force of attraction is there in between the particles. Now, students, there are two types of forces of attraction. Cohesion and adhesion. That is cohesion, it has got cohesive forces. Now, what do you mean by cohesive forces? It is a force of attraction between similar particles. Is what? Cohesive forces. The force of attraction between similar particles. Say, do you know about capillary action? Or we can simply take, just fix a pipe, the PVC pipe, on a tap. Right? And just take it above. The water rises. The water rises up. Why so? Water is moving up against the force of gravity. Force of gravity. Water moving down is okay. It is towards the force of gravity, or it is towards the ground. But water is rising up here. It means it is moving against the force of gravity. Why so? Because the water particles, CH2O molecules, they have got some force of attraction between them. So which is taking them up. So this sort of force of attraction is called as cohesion or the cohesive forces. Adhesion means, or adhesive forces, the force of attraction between dissimilar particles. That is adhesion. Say, for example, just take a rough surface. Say, if I'm taking a log of wood, and its surface is rough. Now if I'm sprinkling some talc over it, talc or any powder you can sprinkle over it, what will happen? These particles stick to the surface of wood. Right? Why they've got stuck? Can't you just move it off? You have to apply some force, or you have to scrub it to remove these particles. Whereas, if on a plain surface, say your school desk, say on which you're writing, the desk which is plain with a Formica tabletop, if I sprinkle some talc over it, so there is a Formica tabletop, and I'm sprinkling some talc. And I'm sprinkling some talc over it. What will happen? Will it get stuck to the surface? No. You can easily wipe off this talc. That is, there is no force of attraction between this talc and table. Whereas, if the surface is rough, there is some force of attraction between these particles and the surface. Right? So what is adhesion or adhesive forces? That is, the force of attraction between dissimilar particles is called as adhesive force. Whereas the force of attraction between the similar particles is known as cohesive force. I'll give you one more example, one interesting thing. Now, say if in a bowl, I'm taking some water. Right? And I'm keeping this bowl in the sunlight. What will happen? Evaporation will take place. Right? Now, which particles will move out? Now, it has been proved that matter is made up of particles, that they are very, very small. And there is intermolecular spaces between these particles. They are in constant motion. So what all particles will move up? See, these are the particles over here. So which particles will evaporate? The inner one or the outer ones? Of course, it's a question of a common sense. And of course, the water molecules present on the outer surface will move up. Then the inner ones. Why so? This is because there is force of attraction between these particles. Now say the particle which is inside is attracted by particles from all the sides. Whereas the particles which are on the surface, they are facing the force of attraction only below and the sidewise. So if they get a small amount of heat energy, they break up this force of attraction and move up, exposing the next layer of particles. So there is this intermolecular force of attraction between the water particles. And water is facing this force of attraction. Say water molecules or the particles, they are facing this force of attraction. Which are inside, they are attracted on all the sides. Right? Whereas which are exposed on the surface, they are facing the force of attraction only below. So the surface water gets evaporated or changes into the gaseous state or the vapor state. So this thing also proves that there is intermolecular or the force of attraction between the particles of matter. So students, this is all about the characteristics of particles of matter. Now I hope you have understood what is matter. Matter is anything which occupies space and has some mass. Right? So these are all the characteristics of particles of matter. Now I'll be concluding this session, students, and in the next session we'll be discussing about the states of matter, the different states of matter and their properties. Thank you, students, for being with me. And just go through your text. These concepts will be you'll be through with these concepts. Just go through your text once, listen the session, and then go through your text. Right? It is going to help you out. So thank you once again, and do have a nice time ahead.